Buenas tardes y bienvenidos. Lo siento, soy un italo-americano ignorante y mi
I am ignorant and my Spanish is not very good, so I am going to switch to English.
So, welcome to our session on coastal marine resources, challenges, and opportunities. I'm Curt Storlazzi with the U.S. Geological Survey's Coastal Marine Hazards and Resources Program. We have 4 presentations today by Edwin, Miguel, Gerald, and Ricardo. Sorry. So real quick, we will have 4 talks. Each will be 10 minutes, and then we'll have 15 minutes of questions and comments. There is language interpretation. Down at the bottom, you'll see a globe. So it's available in English and Spanish. Click on the interpretation and click on the language you'd like. Also, if you're not speaking or presenting, please be sure to mute your audio. And for submissions and questions and comments, write question or pregunta before your question to help us easily identify a question in the chat. And so I will turn it over now to our first speaker, Dr. Edwin Hernández. They'll be talking about coral restoration. Please take it away, Edwin.
All right, there you go. Wait, yeah, thank you so much. Thank you very much for the introduction. Let me see if I got this functioning. Okay, right. I'm gonna speak today a little bit about some of the probably most important challenges, which is how to actually conduct ecological rehabilitation of shallow coral reef habitats, which are subjected to increasing wave action from increasing sea level and stronger hurricanes. This presentation, I'm gonna thank my different collaborators in this effort. So I'm gonna be speaking about different projects that are being conducted either through the university or Sociedad, Ambiente, Marino, which is our NGO that we are working also with. We have several challenges. My focus is going to be trying to address those challenges. And the first one is the need to enhance existing coral propagation efforts and the spatial scale of restoration intervention. So that will require several specific activities like enhancing in situ coral nurseries. We have several projects in Puerto Rico that we are conducting this, but definitely we need to improve, ¿cómo se dice? I'm gonna stop the video just to make sure that I have full power. So we can increase the spatial redundancy of efforts. Second, we need to incorporate additional species. Most of the actual activities of restoration in the Caribbean have been focused on only acroporic corals, but at least through Sociedad Ambiente Marino, we are also tackling other rapidly declining corals like pillar coral, star corals, etc. There's also a need to incorporate different strategies or additional strategies, not only the in situ nurseries, but also expanding locations, introducing microfragmenting strategies, working on the genetic identity of corals, just to understand demographic performance of different genetic individuals, and incorporate land-based nurseries in order to have an alternative strategy that we can increase the number of propagated colonies. And finally, expand the spatial scales of interventions. It's not only about the coral, but also expanding it to the thicket level, the reef level, the seascape level, and eventually across different regions. Not only that, but there's a critical aspect that there's a need to integrate oceanographic dynamics models also into landscape level model of population lambda. I mean, we need to understand where do we have corals that are still thriving or growing really nice? And what are those conditions that foster that actual significant growth? So if we understand the oceanographic dynamics at very fine scales, also we can develop spatially explicit models of coral population lambda, improve identify the areas that are important for our planting, which are those best sites, which still support the highest natural lambdas, which have the best water quality, enhanced connectivity, improve spatial, so we can improve the spatial designs and establish the best fit cross-shore positioning for these interventions. Secondly, we need to restore absolutely wave attenuation on shallow fringing reefs. This is one of the most critical challenges just because we are losing a lot of areas like this example in Rincon several years ago. And when we have very strong winter swells, which sometimes are even worse than hurricanes for this area of the Caribbean, especially along the north, definitely we have a flattening effect. So we need to improve benthic spatial rugosity, need to restore declining shadow coral assemblages, particularly addressing the Acropora palmata thickets, but also we are facing a decline in other really common corals like Porites, especially the finger corals that are being lost in many areas, and they constitute one of the most critical shallow water reef building species. And also probably the most threatening challenge right now, which is how to bring back those species affected by the stony coral tissue loss disease impacts. And this is something that we need to sit down and discuss, and it's gonna be addressed in a meeting next week with NOAA guys. So this is part of the project that I was collaborating with Dr. Miguel Canals, which is going to speak after me. And one of the key products of this project was developing a model of simulating ecological restoration activities for shallow habitats. And the modeling products suggested that actually targeting shallow back reef zones were really important if we are willing to provide some meaningful attenuation of wave run-up. And wave run-up is a key component of the wave attenuation overall scenario. So in order to achieve this, it turns out that actually restoring the shallower parts of the reef are important, but we need to improve enhance the spatial scales of intervention. And by the incorporation of these modeling products, we can understand many aspects of the dynamics of the effects of coral reef restoration. And this is an example of some old stuff that we never got to publish. We felt that we didn't have that many corals. It was only 67 colonies because some of them were lost by wave action. But this is Acropora palmata restoration across a 13-month time period in Vega Baja in 3 locations, and definitely regardless of the size of the original fragments that were generated by the winter storm in March of 2008, we achieved an outstanding recovery of these corals. This is how they look like 8 years after the restorations. So if we have the real nice conditions, we definitely are going to achieve something. So this is community-based work by project local group NGO Piedras in Vega Baja with the collaboration of Sociedad, Ambiente, Marino. So we have shown that palmata can grow very, very well under shallow back reef habitats. The restoration viability supports already the modeling efforts by Canals. That the rehabilitation of this can be used to achieve wave run-up attenuation. This is a viable effort. And by the way, it enhances shallow water essential fish habitats, but we still need to actually provide long-term wave measurements. We need to measure those effects in order to really corroborate what the models are suggesting. And we need to address it on very small scales at the colony level. We need to incorporate our planted coral demographic performance assessments in order to understand where should we put the corals. That means to quantify the spatial temporal dynamics, address response to specific types of disturbance, address effects of vulnerability to disease, syndromes, bleaching, etc. Understand what's the difference between the different genetic individuals, etc. And these are some sort of examples to understand the critical aspect of this. It's just because the viability of populations in the case of staghorn coral or in the case of brain corals, Pseudodiploria strigosa, which has been largely declining due to disease impacts. This is an important element to address. A critical challenge, specifically at least for the eastern coast, is the stabilization and rehabilitation of hurricane-generated rubble fields. Many areas were demolished by hurricanes, so we need to stabilize those in order to start putting back some coral together with the stabilizing structures and bring back the fish that can bring back the clean nutrients for the reef. So this is how they look like when they got demolished. And this is how they look like if you put them back. We have done it and it works, but we have done it on very small spatial scales. Now we need to do it on very large spatial scales. We need to incorporate ecosystem-based approaches. It's not only about putting back the corals of declining populations, but also bringing back the processes of the ecosystem, bringing back the herbivory, bringing back the predators, etc. So if we restore the habitat, we will rehabilitate the actual food web. We, in the long term, can achieve wave attenuation. We can also, as I mentioned, restore the food webs, but we can also restore the livelihoods, the tourism value, the jobs at the local communities. So this will provide a meaningful, fair participation in the blue economy and the socioeconomic recovery. And finally, I think at least for Puerto Rico, we need to sit down and seriously discuss the need to establish a national coral reef rehabilitation program in order to validate the state law number 72 of 2020. The government of Puerto Rico declared coral reefs as critical infrastructure for coastal protection. So this is the way to go. We need to now validate this by establishing a national program, sit down and really discuss the possibility of how can we scale up the coral production and the coral transplanting in order to reach at least a level of 500,000 corals per year. This is something that we can do if we put our act together, put most of our efforts in palmatas, which are the shallow grounds, so we can improve actually the coral reef CO2 sequestration ability and calcification. So we have a healthy growing reef, improve marine protected areas, promote the ecosystem-based management of reef fisheries, improve sustainable and regenerative tourism activities, rehabilitate processes, obviously in the long-term wave attenuation, foster increased connectivity with other habitats, revitalize coral reef aesthetics and tourism and recreational value, and definitely promote blue economy, a participatory blue economy for base communities. But we need to incorporate different societal actors. This is not something that is entirely the government's responsibility or the academia responsibility, but even we need to bring down the private sectors to the table, and we need to sit down all together to discuss this and figure out how to legislate the possibility of recurring auto-financing mechanisms. I don't have the time to get into those details. We can address that if there's any questions. And if you want to learn more a little bit about this, you have my contact information. So thank you very much for the opportunity.
All right, so good afternoon, everyone. So I'm gonna be, nice talk by Edwin. I'm gonna be going a little bit more of a larger spatial scale, and I'm going to be talking here a little bit about the wave climate in the U.S. Caribbean, which includes Puerto Rico and the Virgin Islands, and just a couple of simple aspects that I think are worth discussing. And this is based on some high-resolution climatological wave modeling we've been doing for Puerto Rico and the U.S. Virgin Islands, where we've simulated the wave climate and how it has evolved over the last 40 years from 1979 to 2018. And we have developed an interface, and you can see the URL right here. I won't go into too much of the details, but we've been able to validate this data set, and I think we feel that it gives a pretty good idea of the spatial and temporal structure of the wave climate for Puerto Rico and the UVI. And we developed very high resolution maps of mean wave heights, mean wave power, and you can see the spatial distribution of for example, wave energy. And I think Edwin alluded to the fact that, you know, the spatial distribution of a very high resolution, understanding that spatial distribution is really important for coral reef restoration, also determining the distribution of species and seagrasses and other benthic habitats. But here, what I want to focus on is what's happening to the wave climate in Puerto Rico and the UVI as a result of what we have seen in terms of climate change. So first, let me step back and just very briefly discuss what's happening at the global scale. So this is a nice paper by Bove from Nature Communications that shows that in summary that there's been a pretty steady increase in overall global wave energy. So this means that at a global scale, there's an increase in wave energy because of an increase in wind stresses all over the oceans. But this doesn't mean that this distribution of an increase or decrease in wave energy is occurring in a homogeneous way throughout the globe. So we wanted to look at what's happening in Puerto Rico and how that could be affecting benthic habitats and coastal erosion in Puerto Rico and the UVI. So we wanted to pose the question of, you know, is there a detectable signal in Puerto Rico's wave climate that can be attributed to climate change? So we went and looked at the data from our wave climate atlas, where we have an interface where any user can go in and kind of look at the data and see a time, for example, a time series of wave height distribution or energy or other parameters for the last 40 years. And if we analyze some of that data and we do some hand waving calculations, we can see that as opposed to the steadily increasing wave energy, global wave energy plot that I showed you earlier, in Puerto Rico and the UVI, there's not that type of clear trend in terms of an increase in wave energy. Yes, there's hypotheses that extreme wave events may be increasing and we could get stronger hurricanes. Those are projections, but what has happened historically, when we look at the model results, even though it's for 40 years only, but you should be able to see at least some type of trend, we see that really there's no clear trend that agrees with that global increase that we see in the paper. And why is this? Well, the paper is right, but the paper is looking at a global scale. And you have increases in energy in some locations, decreases in energy in some locations. And in summary, in Puerto Rico, the incoming wave energy outside of the reefs, outside of the surf zone, has not increased significantly. But what is happening, or a question that we can ask is, what is happening at the near shore? What is happening to the near shore wave climate? So we went back and we simulated the time history of wave climate, but using the actual sea level rise rates that we have seen for the last 40 years. So to not get into too much detail, we simulated the wave climate assuming an increase of 10 centimeters, which is basically assuming a sea level rise rate of 2 millimeters per year for 40 years. And that will give us an idea of how much energy is coming into the nearshore waters, impacting reefs, impacting beaches, impacting wet mangroves and seagrasses, as opposed to 40 years ago. And it turns out that it can be significant in some locations. So here's a map of the increase in wave energy due to the observed sea level rise. We're not doing any projections. This is the actual sea level rise we have measured at the tide gauges in San Juan and Parguera. Now, you see all of the blue. The blue indicates that there's no changes. That makes sense because in deep water, a small increase in water level would not result in any changes. But if we look closer, you'll see that in coastal areas, there's significant increases, up to 10, 5, 10, 15%. for very, very shallow areas, including, for example, this is the area of Isla Verde and Condado. There's locations here that I can barely see the color bar with the cameras. Yeah, here's about 15%. This is significant because if we think about it, this is a sustained increase in wave energy that is coming in very shallow water when compared to 40 years ago. The explanation for this is simple. It's called depth-induced wave or depth-limited wave breaking. If your water depth is 1 foot, so 0.3 meters, and you increase it by 10 centimeters, you're on average getting 33% more energy if you just look at the depth-limited wave conditions. But it is significant. So what I'm getting at is that we talk a lot about incoming changes due to the climate change for the wave climate, but really in deep water, there is no detectable signal. But if we look at what's happening very close to shore, there is a signal. There is a clear increase in incoming wave energy. Does that mean that we have more coastal erosion? Not necessarily. It means there's more energy that could lead to more erosion or more accretion in some locations. But the key take-home message here is that realistic simulations that we've been doing show that even in the absence of an increase in energy in deep water, so there's no evidence that waves are getting bigger or smaller. The nearshore wave climate, due to a small increase in the sea level rise of 10 centimeters, is already generating an increase in incoming wave energy in shallow water. Now, this is a conservative estimate, and I'll finish up with this, because we're not taking into account the effects of increased incoming wave energy associated with changes in coral reef cover or the destruction of coral heads and benthic habitats. So I like this estimate because it is conservative. It is definitely much more, and I think Curt's work has recently, shown that you definitely have an increase in wave energy with a reduction in coral cover and overall coral reef health. So I'll leave it there, and then I'll take any questions later. Thank you.
Gracias, Miguel. That was a great presentation. And thanks for staying in the channel.
Thank you, Miguel, for the presentation.
Questions until the end of the session so that once all the presentations are done, we can ask then. Our next presentation is by Dr. Gerald Bove, and he's going to be talking about coastal infrastructure at risk in the U.S. Virgin Islands.
Okay, first I'd like to acknowledge that I am in what were traditionally Iroquois land, just outside of Cooperstown, New York at the moment. And I'm going to talk a little bit, not only about the VI, but about an inventory and exposure assessment of Caribbean-wide critical coastal infrastructure and some methods we developed starting about 2 years ago to create geospatial data at the regional level. But these methods and data can apply even at the local level. So my interest is in long-term spatial temporal monitoring of both natural and built environments and community citizen science participation. So I try to keep things fairly straightforward and simple, and that was our interest in developing this method and these data. So we saw a need for uniform data for the evaluation of exposure and vulnerability of coastal infrastructure across the Caribbean, and a method to understand what elements of critical coastal infrastructure are exposed. But at the end of this talk, I'd like to bring in something that I think is pretty important and is rarely discussed in terms of critical coastal infrastructure and exposure and vulnerability, and that is, well, we'll get to that when I get there, sorry. So approximately 60% of the region's population, most of the region's population and economic activity is centered along the coast within 10-meter elevation of the coast. And surprisingly, there has not been a lot of really uniform evaluation of what's exposed and what's at risk. I worked with the University of the Virgin Islands on the hazard mitigation and resiliency plan over the past year and a half, looking at what's exposed in the territory. And of course, you know, the US territories have far better data than many places in the Caribbean. And good data are available, but they were siloed and often not accessible. So a couple of years ago, we decided to have a look. So could we develop a straightforward data collection or generation procedures, inexpensive tools that were easily accessible with that incorporate both local knowledge and not a heavy reliance on consultants to look at what is exposed to coastal hazards, particularly hurricanes, but not necessarily only hurricanes or tropical storms. So we developed, to do this, we developed a spatial database of facilities. We needed a digital elevation model. We needed to know something about extreme sea levels and the software to tie all of these data together. So the idea is that the assessments can incorporate high-tech tools and analysis, but still be accessible to people who are not professional GIS analysts or climate change, working in climate change, et cetera, available to local governments or anyone who might be interested in looking at what is exposed along the coast. So we spent about a year looking at different sources of data, and we basically quantified the error and uncertainty both in those data and in the methods. And I believe have made these accessible now to just about anyone. So we spent this time collecting airports, seaports, power plants, primary roads, oil refineries, wastewater treatment facilities, wind farms, solar farms, everything from major container bulk liquid fishing ports to small piers, jetties, and wharfs, and went through this criteria to see what was active and what belonged in the database, and created this regional database that when matched against, and then reached out to several local governments and found that we did a pretty good job. In fact, oftentimes found things that were missing from their databases. We, of course, were also missing things. So that's one component, that first component, the spatial data. The next is we looked at not all areas, of course, LiDAR data are the gold standard, but not all areas have LiDAR data. So we looked at SRTM data, and we looked at something called the Coastal DEM30, which is produced by Climate Central. And we spent quite a bit of time comparing the outputs of the models from those various DEM sources. We looked at an extreme sea level model that considered max tide, episodic coastal water level rise due to storm surges and wave setups. And all of these data are publicly available. And we spent a lot of time looking at the impacts of the digital elevation models. So we compared the LiDAR data to the coastal DEM to the standard SRTM. And the results were pretty good. I mean, LiDAR is certainly the gold standard, and we tended to underestimate coastal flooding, but we did a lot better than the generally available flood maps. I'm not going to say too much about that, but the data sets we produced using strictly free data and free software, publicly available software, were pretty darn good. Nearly as good as anything that has been produced or can be produced. And because this is all accessible, it's quite easy to run these models for different scenarios. So the climate model, the coastal storm model can be run for RCP 4.5 throughout different timeframes, the year 2050, the year 2100 for 8.5. So you can start to look at different scenarios and how the coastal areas and coastal infrastructure might be impacted. But one thing, and so all of those data and methods are available. I'll show the the references for that next for people who are interested in replicating that. It's pretty straightforward. And you can understand what so we've quantified the error in those assessments. But one thing that is striking, even looking through the literature, it's only maybe been the past year or two where we're seeing more publications and what's really missing from exposure assessments and taking it to that next step of vulnerability. So what's vulnerable? And this is the impacts of socioeconomic equity on critical coastal infrastructure. So we know that that unsustainable resource use and the maldistribution of resources drive risks towards vulnerable populations. But we also know that individuals within those vulnerable populations occupy a large proportion of the essential workforce in many critical facilities. And to keep those facilities running requires everything from baggage handlers to the cleaners to ticketing agents. And it's rare that even at the individual facility level assessment that the impact that the exposure of the folks that work at these facilities and keep them running, and I'm not talking about the upper management, et cetera, and the administrators, I'm talking about the people that are required to be there in order to keep these facilities opened either during or after a storm, are often the ones most exposed. And so if someone's house is destroyed, their ability to be at work functioning is diminished considerably, as well as if that neighborhood is flooded and they're unable to pass in a roadway in order to access that facility. Those things are rarely considered even in facility level assessments. We tend to focus almost exclusively on infrastructure and on the physical facility rather than on the folks that keep these facilities going. And we've seen within the pandemic that can be quite mistaken. We've seen food facilities go down due to lack safety and health regulations for the workforce, and we've seen that interrupt supply chains. We've seen supply chains interrupted by transportation, drivers not being available. So there's quite a few things that we need to consider in order to really look at what is exposed and what is vulnerable. And it's very rare that we actually take that workforce into consideration. So developing methods to do that are quite important. There are some papers that have addressed this, and the Cayman Islands has looked at this to some extent, but really it's quite missing in a large part of what we do in this area. So I'd just like to put these references up. So using these two, just looking through these two papers, they're quite straightforward. You can both understand what the error or uncertainty is in your exposure assessment using these methods, but you can also understand how to conduct these assessments without having a necessarily professional come in and teach you how to do these things. And I'm open to questions, or if anyone would like to reach out to know more about how to run an analysis such as these, please do so. Here are my contact information.
So up next is Dr. Ricardo Colón, and he's going to be discussing managing coastal reserves.
Well, hi, good afternoon. I might have some problem with my internet. It's usually not very good, so please let me know if you cannot hear me well at any time. So one of the challenges that I had for this presentation was having just 10 minutes, and there's a lot to talk about. But what I'm going to do is I'm going to be switching between a story map that I have prepared with some updates on management of the natural, and then a PowerPoint that I usually do. So for those of you who don't know me, my name is Ricardo Colón. I am the management officer for the natural protected areas of the northeast of Puerto Rico. I work for the state agency for the Department of Natural Resources, and most of my talk is going to be focused on the Northeast Ecological Corridor and the Laguna Grande Bio Bay, which is a bioluminescent bay that we have in Fajardo, and some efforts related to the several issues that Miguel and Edwin just mentioned in the earlier presentations. Okay, so In terms of the Northeast Ecological Corridor, this is the area that we're talking about, 3,000 acres in between Luquillo and Fajardo. Most of the work that we have done in the past, the context of climate change, have been basically building capacity. So there is almost no capacity for management on other areas in some areas, and the northeast of Puerto Rico is an excellent example of that. Capacity means personnel, monitoring capacity, and any type of capacity management action. So in the Northeast Corridor, a relative natural protected area, it was designated to 2013. We started by doing soil stabilization projects, protect the coral reef areas particularly the Punta La Bandera coral reef in this area right here. It was very muddy, very disturbed sites, and it was also the main entrance of the reserve. So in terms of management, it was also important for us to have access. There's actually a story map about all of that management action, and I do recommend that if you're interested in that management action, you can refer to that. I'm gonna put some links in the chat so you can take a closer look. Then we started with the signalization, signaling effort. We started putting new signs all across the reserve, and signs that were close to reflect the management problems that we have been documenting. And then in more recent years, we started doing something that we discussed with, but we wanted to first do experiments, particularly on what it has to do with access to the different public areas of the reserve. So this is are areas that have been open to the public for decades, and now we're starting to control vehicles and do all sorts of things. So we kind of slowly, except for the accesses to the maritime zone, which is a very important habitat for the leatherback turtle. So this access, closing this access to the beach, vehicle access, have been very important. And there's also the development of long trails. So right here we see Las Cabezas de San Juan and El Yunque, and we can see that the corridor is right in the middle. So there's a current effort to develop a long trail, connect all of these natural protected areas, and we have been working pretty hard on that too. So that brings me to the hydrological that I think is going to be the basis of the restoration corridor. And right now I'm going to jump real quick to my. So this is what's going on in the corridor. In Puerto Rico, the legacy of land uses in terms of forest recovery or land use recovery of natural ecosystems, or at least ecosystems that provide basic ecosystem services in the coastal areas has not been the same as the rest of the island. And that has to do with the agriculture practicing areas. So uplands were usually either shade coffee or grazing cattle. So as soon as the agriculture was abandoned, most of the agriculture and forward, there was a lot of natural recovery. Of course, there were big efforts of reforestation that were also concentrated. So forest recovery in Puerto Rico has been excellent, but has also been mostly restricted to uplands. In the coastal areas where the sugarcane plantations dominated, and particularly those areas that used to be coastal wetlands or freshwater forested wetlands, of the degradation of the soil and the hydraulic that basically caused a stop to the succession of the natural recovery. And this is exactly what we have in the corridor. It's reflected in our most recent habitat map. This is a 1998 map. It shows that at least half of the terrains in the corridor are degraded areas that are covered either by invasive, herbaceous wetland or herbaceous areas that are very low in diversity. We do need to intervene and rehabilitate that area, restore in the best way possible. And for that, we have several projects that are going on. Well, most of them have to do with the hydrology. And you heard Miguel talking about the wave models. The project that we have contemplated for the corridor also includes one of these waves. Very important for us to understand because of the many stories that we have in the corridor and the dynamic opening and closing of estuary. So the other big thing that we're planning for corridor is the high resolution habitat map. So the map that I just showed you is images were probably older. We're going to the hydrology to understand the current hydrology conditions corridor. We're going to verify the that we plan to update very frequently through the use of our own drone hydrological imagery that our own drone. So I see that I have approximately 3 minutes left. Now I want a little bit of corridor and talk about Laguna Grande, which is the bioway that we have right here, and that we have right here, and management efforts in this. This is another natural, and our most important action that we have done recently is the rehabilitation this area. So this area was as a ramp for jet skis. So it was very very technology because it was altering the bioluminescence. Another thing that is really important for the bay and the bioway lagoon is the sargassum, and this is also like connected to climate change, but also very connected to just man-made other parts. So we know sargasso is gonna keep coming, and we know that sargasso is a big influence of the benthic habitat and the biome. So our plan is to basically focus on the management on how to prevent sargassum from getting into the lagoon and maintaining it on the coastal bay. So we use the information that we have, the current spatial information that we have, bathymetry and benthic habitat, and we are proposing a system of booms of floating barriers that look like this. They're called the beach bouncers. This is just a brand that we selected, but it could be any floating barrier. And we propose this design not to interrupt the boat traffic that is in this area. And the idea is to maintain the sargassum per part of where it's most susceptible not die and not that decomposition, which is detrimental. Of course, there's also a very shading effect on the benthic vegetation. So the position of the booms also accumulating the sargassum over muddy bottoms and not seagrass. That was really important for us. And then we are going to acquire electric boat to manage any sargassum that does enter. So I think it's a very comprehensive plan for phase And it's funded by NOAA, a proposal that was written to NOAA for critical because this is critical habitats for many species of fish. And lastly, let me know if I went a little bit over my time, but I want in support of the work of Edwin and in terms of the management, Marino, Arrecifes de la Cordillera, and basically all of these coral reef areas. What can we do to support that as an agency? So there's we recently got awarded funding by Fish and Wildlife State Action Grant to develop a nursery for marine invertebrates for and for coral fragments that we can reproduce in the nursery. To basically try and support this activity that other groups and other our restoration are developing and have been doing for the last couple of decades. So that's it. Any information I'm available.
Okay. Well, gracias for all the speakers. I guess if there are questions.
There's one for Dr. Jerry Bove.
Okay, so someone asked, well, there's one from Jerry to Edwin. Can you say something regarding beaches? And I guess this is to all speakers because I think others could help address this too. But first off to Edwin, can you say something regarding beaches and the potential of the long-term impacts of reefs on beach erosion and accretion?
That was a great question. I was actually trying to start to respond it in the chat, but yeah, that's easier like this. Actually, Dr. Canals and I just completed a project for NOAA Coastal Resiliency Program, which actually address on a very fine scale what are those dynamics on 2 locations in Puerto Rico, along Palominos Island in the northeastern coast in the La Cordillera Reserve that Ricardo was mentioning, and also of Palmas del Mar, which is a very important residential area along the eastern coast in Humacao. And I can tell you, in the case of Humacao, Hurricane Maria, which actually made landfall across that area, they lost probably over 20 meters or more of the actual beach that used to be there. It's like a meter underwater right now. There was a massive destruction. Even some areas of the back reef exposed former Acropora palmata stands that are now like 2 meters below surface. So it was, for me, such an impressive sighting, and I took plenty of pictures of that. My point is that yes, there's an increase in erosion in some areas that have undergone major degradation. I have a couple of students working with me right now, their dissertations working on that aspect, because I think those really shallow fringing reefs are the forgotten reefs, at least in Puerto Rico. Most of the field work is being done. Actually, I think it's a planetary thing. You know, most of the people pay attention to real reefs in deeper waters, but I think it is becoming increasingly important to understand those community trajectories on these shallow habitats. So we are actually addressing from the long-term monitoring standpoint, trying to understand what is going on. I think it's critical, absolutely critical, to address the demographic performance of outplanted corals. So that's why the kind of experiments that we're conducting are important, so we can understand which corals can survive different scenarios, because you have some shallow reefs that are really nice under very nice water, but you have some others in metropolitan areas that are really awful because of water quality issues, sediment pulses, etc. So we need to understand which kind of corals can withstand those conditions, so they can be put back on the reef and can make it, you know.
Are there any other questions for our speakers? I think Miguel had to run out. He's working on trying to stop some sediment impacts out like by Tres Palmas, so he had to leave. But if there's no other questions, I have a few. So Jerry, you were mapping the coastal infrastructure at risk. At least in Puerto Rico or USVI, did you use HAZUS or NSCI information, or were you using larger standardized databases?
No, we didn't. We used a database from the, so we were only looking at exposure. So what was exposed? So we created our own spatial data, both from different sources for locations, which tended to be point data, and then went and had students. We actually had a bunch of students digitize coastal infrastructure and then looked at the differences. So we wanted to know what would be the impacts of heads-up digitizing to the accuracy of what we were trying to capture. So we spent quite a bit of time looking, reaching out to different governments, looking for spatial data for critical coastal infrastructure with really very little success. And then in terms of the storm model, that came from a model from the Joint European JERC.
Roger that. Any other questions? If not, I'll ask about Ricardo. Similarly, just asking about mapping. You were talking about using some drones for high resolution mapping. I'm wondering if there's been any thought. DigiGlobe has a satellite called Worldview 3 that has multispectral data now at about 2.5 meter resolution, and thus you could characterize not only potentially do species, but how they might change through time. I don't know if you've looked into that or if you could speak to that.
Yeah, sure. Yes, definitely. I had a recent conversation with a colleague from NOAA that was, we were discussing all of this. They're working on the CCAP effort. And I was made aware, I'm not a remote sensing expert, of course. The idea of using it comes for the basically multiple things that we can do with it. So getting imagery immediately, like high resolution imagery immediately from certain areas, has allowed us to respond to basically impacts, like illegal logging and impacts in the shore. The drone will also have a thermal camera that we're going to use to monitor wildlife, specifically leatherback sea turtles and cattle and wild horses that we have in the reserve. And the amount of space that we can cover with the drone also will allow us to do a lot of our monitoring much more rapidly, right? So it's basically like many things that we plan to do with mapping. But of course, the mapping effort is not tied to a drone. If there's another product, we're just basically interested in updating the habitat map. And we want to do it as soon as possible because all of the projects that I mentioned, specifically the hydrologic study, is already funded, and we're going to be starting with that very soon. So we want to have a habitat map that has a good resolution of the reserve as it is today before we start doing major plantings or major hydrological restoration. For us will mean, for example, the rehabilitation of channels. So we're gonna be moving water to places that are currently dry. So that's gonna be an ecosystem change that we wanna be able to monitor through multi-resolution imagery to see how the vegetation responds. Yeah, the drone will help us with that, but definitely any other product and any other agency, of course, and experts that support that will allow us to reach the main goal, which is habitat monitoring on a recurring basis. We're aiming for 5 years maximum repetition of the maps.
Excellent. Okay, well, that's all the time we have now. I'd like to first thank, Edwin, Miguel, Jerry, and Ricardo for their presentations, which will be recorded. Hopefully folks have been adding some things in the chat, and hopefully some of those presenters can continue to address those questions. But we, and so I guess just wanted to wrap up and say gracias a todos por vuestra participación.
Thank you all for being here. I'm sorry, I am an Italian American and I am ignorant. I hope that you can enjoy the rest of this event.
Thank you.